Wednesday, section 7.2, let's grade it. Number 4, equilibrium point. Number 10, take your two equations. They chose elimination. I think that's easiest. Some of you might have done substitution. Ugh. Long story short, you get what kind of statement? False. You get a false statement. Hence, there are no solutions. The lines are parallel. Number 20. Huh? Uh-oh. It must have been like a sign thing that went wrong.
When you're dad.
It happens. It happens. Probably a seal died in the making of that problem we're solving. 0 equals 8 is false, so none. Number 20. Long story short, y equals 5. Plug it in, x equals negative 17. Remember, get the right answer. Negative 17, 5. Number 34. You're a false statement again. Hence, it's none. It's inconsistent. Should be parallel lines, and that matches with letter D. Number 34. The math gives you a false statement. So they better be parallel, which would be letter D. Number 46. You guys could look back in the examples in this section to see that in order to find the equilibrium point, is it supply and demand? Is that right? Okay. With supply and demand, we just set them equal to each other. Equilibrium point is when supply and demand match. So all you have to do is set the two equal to each other, solve. You end up with 500 as x. You can plug back in to either of the equations. I think they wanted profit. Plug back in and find y equal to 75. Is that it? That's it. Any quick questions on 7.2? 41. Any other questions besides 41? Okay, I'll get the book open so you can peek at it, but as I do, let's go ahead and go check 7.3a. I am recording, so if you guys got a little behind, maybe catch up with it this weekend. You'll know where to find it to grade it. That's fine. Okay, let's keep going to 7.3a and then we'll come back to the questions you have on 7.2. Remember I split the homework into two different parts yesterday? It was up on the board. So 7.3a was pretty much over what we talked about yesterday, and 7.3b we'll just go into a little bit more depth. Number 8. Number 8 is a no, yes, no. No, yes, no, no. You didn't have to solve the whole system. You were just checking the solutions. Make sure you read directions. No, yes, no, no. Number 12. Was it already in the stair step? Go team. All you do is go back and plug in, simplify, solve, go back and plug in, simplify, solve. Final answer for number 12 is 2, negative 3, negative 2. 2, negative 3, negative 2. Number 22. So there's a little baby system. They still got it in a stair step. You would have only had to do one link though. Wouldn't have been a very long system or a very long process. They went ahead and got it in row echelon form. All you do is go back and plug in. You get the points negative 3, 2. Once again, they were following the system. Yes, you could have done elimination or substitution. They were just following the system. Number 42 though. Ugh. Number 42 is like what we saw yesterday in our notes, not that, sorry. Number 42 is like the last problem that we did yesterday in the sense of the approach you had to take. So, thinking the first two, thinking the last two, thinking the result would end up getting you, what? Did anybody get confused when you tried to do your stair step and the Z one just went away? We better see what's going on with this today, because if you look at the answer, they still have an answer, but there's this weird A thing. There's this weird A thing. So if I were you, and if you got to number 42 on 7.3a, keep your homework out, because you might have gotten stuck at that point, and you will learn how to keep going today in class. And I think, was that the last one? That was the last even. So number 42, if you had a question on it, just keep your homework open to that. For those of you that didn't do that homework last night, well, I guess you won't get stuck on this problem very well. Bummer. But why don't you get stuck on it so that you could come back today and be like, how do we solve that one? Were there any other questions on 7.3a? All right. So far, or we need to still do it tonight? Okay. Let's go ahead and go check out that question from 7.2, number 41. I can open it up, and if it works, what do you guys think? Is it going to work today?
Probably
Moment of truth.
not. Work.
Woo! Look at that. Go team. All right, here we go. Hey, airplane speed. That sounds familiar. I think we did one of these recently. An airplane flying into a headwind travels through the 1,800-mile flying distance between. Let me see if I can actually. Does this let me go smaller? Hey. Can I fit it? We'll try. Okay. An airplane flying into a headwind travels the 1,800-mile flying distance between Pittsburgh, Pennsylvania, and Phoenix, Arizona in 3 hours and 36 minutes on the return flight. Oh, that's right. There's the whole like wind is subtracting, wind is adding thing, right? Where should we go in our notes to help us with this problem?
Problem.
Check it out. How are we going to do it for this problem? Well, a few things are going to change, but not much. What's going to change, kiddos? The numbers. Instead of being a 2,000-mile trip, what's it going to be? It's going to be 1,800-mile trip. Instead of going in 4.4 hours, how long is it going to take us?
3.52.
3. Yeah. And how did you find that? Couldn't you do 3 plus 36/60ths? Wouldn't that work? 3 plus 36/60ths of an hour. But some people have already done that work for us, and they figured out 3 point, what was it, 6? And then the other one's going to be 3 hours. And guess what we're going to do? Solve. So we set the system with 1,800 equals P minus W times 3.6, and 1,800 equals P plus W times 3. Solve it and see if that helps. That's how I would have done it. Solve it and see if that helps. All right, any further questions, you can go ahead and ask me during lunch or after school. Let me get rid of all my little markings on this example. And let's go back to section 7.3 and figure out what on earth is going on with 0 equals 0. Like, once again, what happened in number 42? It was going, there's a stair step, and then boom, I'm stuck. All right, let's check it out. Okay, before we get to number 42 real fast, though, we actually skipped this page yesterday for sake of time. You guys don't have to draw this. I promise you don't have to draw this. If you want to, though, it's kind of fun. Won't lie. But instead, I do want you to write down the words for the types of solutions once we get into three-dimensional systems. Wait a minute. How are we three-dimensional now? What's going on? What's changed? Exactly. Did any of you guys have Mr. Shanks for geometry?
Yeah. Set up his room.
When he set up the room with the
X, Y, Z, the word now.
like that.
I miss Keith.
I know.
Goodbye, Mr. Keith Shanks.
Well, that's 2 teachers we had at math.
You guys heard he had another
Do you know
sound.
the name of the son?
Oh, the new one? I have my phone.
Yes,
Charlotte.
created names for all. I wonder.
What has happened to Mr. David Crawford?
He's still rocking it. Just not-
Does he still have an emo picture on his website?
Oh.
On his new one for hard time. Alright, here we go. We're in the third dimension. Kiddos, why? Why is there only one point when I see all these different intersections going on in this picture? Look, it's intersecting, it's intersecting, it's intersecting, it's intersecting, it's intersecting. I don't get it. What's
There's
going on?
one point where all three
There's only one point where all three of them,
Planes.
Yeah. because if we have three equations, three three-dimensional equations, we're talking about three different planes. Not lines, but planes. And they all only meet in one spot. So you could be consistent and have only one solution. You could be consistent and have a whole line of solutions. Now hold on, how many points are in a whole line? Because remember, all of these keep expanding, right? Infinitely many, but limited. Huh. Infinitely many, but limited. I'm gonna put a little. With A, when there are infinitely many but limited solutions, like there are infinitely many but only on that line. For instance, if I was to put this little point right here, who's a valid point? Is he a solution? No, because he's not on the line. So wait, infinitely many means infinitely many but not all? Yep. There are types of infinities that don't include everything? Yep. There are varying degrees of infinity? Yep. Anyway, we'll stop talking about that. It's very interesting. Meaning, the infinitely many points on the line is going to be less than the infinitely points on a plane, right? Which is going to be less than the infinitely many points on all the planes put together. Anyway, move back. Long story short, what you're going to get on this one is something like 0 equals 0. Wait, we just saw that. And then last but not least, there is another type of consistent. The other type of consistent is like infinitely many as in all the points, meaning all the equations are equivalent. Meaning they're all the same equation, just different multiples. They're all the same equation. Which means they all, or all the planes are the same. So all the planes could be the same, or all the planes could intersect in a line, or all the planes could intersect in a point. However, to be inconsistent, all the planes could not intersect whatsoever. All the planes could not intersect whatsoever, like none of the planes intersect with any of the other. They are all parallel. This would be no intersections at all. However, there is another way of being inconsistent, which would also be no solution. This one would be, do you guys see the empty space in between? They intersect each other. Pink and blue intersect. Yellow and pink intersect. Yellow and blue intersect. But what happens or what doesn't happen in the middle? All of them, all three of them do not intersect. Does that make sense? So intersections, but not all three intersect. Okay, anyway. You're not going to have to do sketches of these. It's just trying to basically expand your knowledge of consistent and inconsistent to three-dimensional systems. No graphing three-dimensional points today.
What are the shapes
What shapes?
that you have to draw when you photograph like
Oh, true. That was pretty cool. Absolutely.
Is that only geometry?
Pretty much only geometry.
Oh.
Unless we start talking about the fourth dimension one day when I'm bored. Okay, so. Yesterday. Well, first of all, what do you guys think? Consistent or inconsistent? The last one that we saw. Consistent or inconsistent? Consistent! There's an answer. If there wasn't an answer, it'd be inconsistent. Which type of consistent? One, infinitely many but limited, infinitely many as in all. One. So it's that picture where all of them intersected in one point. So what on earth was going on in number 42? If you haven't gotten there yet, you might be very, very interested because I'm about to start it. Number 42, let's review our system from yesterday. Let's start with a problem that is hidden, hopefully, right behind this. Where is he? There he is. Okay. You guys help me review. 2x plus y minus 3z equals what? 4? Read off the next equation. It's faster.
4x 2z equals 10.
Keep going.
Negative 2x plus 3y minus 16z equals negative 8.
Let's figure out what on earth went wrong. Number 42, something went wrong. Something went weird. Something went crazy. But what? Alright, cool kids, review with me. What is the, hopefully the air is turning on soon, system? What do we do first? What's the system? Link them! Link the first two, link the second two. Remember, we're not robots, so theoretically we could take different approaches, but the system says link the first two, link the second two. What do we do with those links?
You do elimination. Or
Do elimination.
Just try and get mix of one.
I think I'm going to multiply this guy by something, yeah?
3
Negative
halves.
2 sounds good. Oh, you're trying to make the z's match? No, we always try to cancel out the x's. So multiply the top one by negative 2 sounds good.
Oh, I don't know what I was doing.
True, but we are trying to learn the benefits of following systematic thinking, like for computer programming. Equals negative 8. Double check. Ooh, good catch. I got busy talking. That's always dangerous. Life lesson. Okay, so. You guys agree? Okay, let's rewrite the other one. Alright, you guys agree? Yeah, and then the distraction can cause destruction. Ooh. Should've gone out.
Such as a jet pilot looking at his iPhone.
Okay, we got one. Let's go do another. I think the top guy's okay, right? Let's keep the 4x. What should we do to the bottom guy? Yeah, multiply by a positive 2 is good, because then that'll be a negative 4x plus 6y. I got it this time. Minus 26z equals negative 16. Let's add down. We're eliminating the x terms, following the system. We have 6y minus 24z equals negative 6. Okay, before I go on, someone, hopefully many of you, are double checking my math. Are we all matching up? If you don't match up, you're finding mistakes somewhere and fixing it. Now what? We linked the first two, we linked the second two. Now we gotta link the resulting two, right? That 6y one looks good. Let's keep him. But what are we gonna do to that top one, I think? Multiplying by 3? That sounds good. So we get negative 6y plus 24z equals 6. Let's go! Double check. 3 times negative 2 is negative 6, 24, and then 6. Negative 6, 24, and 6. What happened?
Wow.
Isn't that 0 equals 0? But I was counting on that, wasn't I? Does that mean I did something wrong? No. No matter how you would have gone about trying to do it, you should have gotten to the same conclusion. Struggle. So hold on. Who are my keepers? First equation looks good, right? I guess we could choose the second equation. But when we go to choose our third equation, what's wrong? I mean, it's true and all, so that means that there's an answer, but how do I express it? Infinitely many, not good enough. Infinitely many, not good enough. So here's what we do. We make our system. And let me go ahead and write it this way. I think I lost some of you guys yesterday when I started multiplying by 1/2. Yeah, let me just write it this way for now. I have negative 2y
something that like on the z-axis, like it's always true? Is that like what it's saying? No matter what you
Yes.
plug into it,
You can see it as the line is on the z-axis, or for all values of z, I suppose. There are points. But technically, you could almost say for all values of. Oh no, the line would be parallel to the z-axis. Yeah, the line would be parallel to the z-axis. Wait. I didn't put 0 equals 0. What did I put instead? Here's the connection we need to make today. If we get a 0 equals 0, we have to say, all right, fine, z equals a. What? The 0 equals 0 means there are infinitely many solutions for z. Oh. But we can't just say all points because it's not that whole every single equation is the same because they're not. Look at them. He has x's, y's, and z's. He has just x's and z's. They're not all the same. So it's not that picture where you have one plane and that's it because all the planes intersect. It's not that one. What picture is it? Yeah, it's the one where you have like the fan blades. Like you have this guy going to here, and then you have like another guy who's going like a here. Then you have like another guy that's going like a here. I don't remember what the colors were. Yes, I know my artistic ones. You can do a better job than I. But long story short, you end up with they all intersect in one line. Basically, it's like fan blades, kind of. So, long story short, we can't just say infinitely many and be done because that's not how simple it is. So we let z equals a. Now, technically, for our stair step, we should go ahead. Why am I in blue? I don't know. We should go ahead and get rid of our leading coefficients. So we multiply him by 1/2. And then multiply this guy by -1/2. To get it in row echelon form, so I'll have x plus 1/2 y minus 3/2 z equals 2. I'll have 1y minus 4z equals -1/2. But even though this is a proper row echelon form, we still have to, and even though z equals a, we still have to back substitute. So let's go. Plug it in, plug it in. Y minus 4 times a equals -1/2.
Isn't it minus -1 for the y minus 4z equals -1?
Let me check in. Good, bad. Good call. I didn't multiply it. Alright, we're plugging in, back substituting. We have y minus 4 equals -1/2. That's not going to be -1/2 anymore. What is it? -1. Solving for y. Y equals 4a minus 1. So believe it or not, we're actually getting answers. They're just in terms of a. Infinitely many z's. Y's and x's depend on those infinitely many solutions. So I plug in again, x plus 1/2 times who is y? 4a minus 1. Minus 3/2 times who is z? A equals 2. Ashley, go ahead, Kim.
When you found out that 0 equals 0, why did you use those new equations?
When I found out 0 equals 0, I made z equal a. Because this was supposed to find my z and it didn't. So that was showing me that there are infinitely many values for z, but we're still limited, so we have to go ahead and let z be a variable. And we're going to use that variable in our stair step in order to get like equations for which x's and which y's go with all of those infinitely many z's.
But why did you use the first two equations above z equals a?
Oh, well, did you see where these came from? I had my first keeper and my second keeper, and then I said, uh-oh, I don't have a keeper. All right, fine, my third keeper. Then, row echelon form technically says we need leading coefficients of 1. So I was just following the system in the sense of technically get leading coefficients of 1. But if you see it, couldn't you plug in z equals a and you would still solve for the same answer I'm solving for? Yeah. I was just following the technicality of making each of the leading coefficients 1 first, then going on. Good question, kid. So coming on back. We've plugged in for x. We're trying to find x. Some of you guys hopefully have already beat me there. That way you can double check my math and make sure that I'm not going crazy or doing illegal math all over the place. That's going to be x plus 1/2 a equals, we can add the 1/2 to the other side to get rid of him. 2 plus 1/2 would be 5/2, right? Then we'll subtract the 1/2 a. And we end up with x is equal to, there are different ways of writing it, but you could do 5/2 minus 1/2 a. We'll see if the book matches up with what we got. Remember PEMDAS, we have to keep these separate because they're not like terms. If you knew that, thank an algebra teacher. You got you algebra?
Yeah.
Yeah, for some people.
Like one of the sections.
Oh. You caught algebra.
I'm pulling up Microsoft Word. What is the solution? Let's see. Negative 1/2 a plus 5/2, or 5/2 minus 1/2 a. Did we get it? 5/2 minus, yep, we got it. 4a minus 1, got it. And then a. We got it. Let me get rid of that homework. Because we just figured out number 42. But what happened, guys, that made all of this kind of go a little wonky for a second? 0 equals 0. And who were we trying to find with that last step? Z. Since we couldn't find Z, we said, all right, fine, Z, I guess you're everybody, so let's let you equal A. Now, today in section 7.3b, which you guys don't have to call 7.3b, just keep going in your 7.3 in your notes. We're going to see another time that things go a little bit weird. You ready?
No.
Okay. Deep breath. Let it out. Here we go. Oh my goodness, what's wrong? What's wrong? What? They gave us an impossible problem.
Yep.
Drop the pen, walk out the door, let's go.
Alright.
Just kidding. Don't do that. What if there are not enough equations in the system? Then there will not be just one solution. But we can still find the solution form if we picked left. What did we do just a second ago when we didn't have enough information?
Let z equal a.
It's just like us having a third equation of 0 equals 0. It's just like us having, because we could make a third equation and say, yay, go team. But it doesn't help. So we can see a non-square system, aka 2 equations with 3 unknowns, as a consistent but infinitely many but limited example. We just have to go ahead and say let's z equal a. And here's the crazy thing. Some of you guys are like, hey, I can solve this on my calculator. I know how to use matrices. Pause, that's chapter 8, number 1. But number 2, can your calculator solve something like this?
No.
No. It would say it's impossible. And we say, no, it's not. There's just infinitely many answers, and we'll find expressions for those infinitely many. So what do? We go ahead and say, let z equal a. We add to the system and we say, all right, fine. We really can't solve anything unless we have 3. So since there are only 2, pretend like it's 0 equals 0, because basically it could be, and we plug in, we throw in z equals a. But oh, that's right. We didn't do any of our links, did we? All right, hold on. Where's our system start? Take the first 2. unforeseen. What do you guys think? Multiply the top one by? Yep, because we always cancel out the x's. So multiply the top one by -2. We can have -4x minus 6y minus 6z equals -14. Let me be quiet as you guys double check the math. Even though it looks funny, we're still doing the system. Link the first two. Let's go. X's cancel, yeah. 12y plus 9z. Sounds good to me. Link the next two. No. Wait, why not?
Because there is no next two.
There isn't, right? I mean, there's a second, but not really a third.
Those are your.
Do we have enough? Oh wait, who's a keeper?
What are you talking about?
And then the. Oh, that's right. We don't need to go any further. We have our 3 keepers. Let's take them off to the side and see what we can do with them, huh? So we have our first equation in 2x plus 3y plus 3z equals 7. We have our second equation in. Can we divide everything by 3? Is that okay? Make it a little bit easy. So we have 4y plus 3z equals 10.
If we wanted, could we take the, well, can we take the 4x plus
If you
18y
wanted.
and divide it by 4?
Well, but 15z.
Yeah, it's just there's 3 odd.
I guess you can choose either of the top
Yeah.
two. Yeah. You can choose either of the top two. Now, if you were programming, you would always have it choose the right one, but the computer's doing all the work, so who cares? But yeah, once again, we're not robots, so yeah. That'd be okay. Ashley asked earlier what I did when I went from a messy system. It's not messy, but when I multiplied my first 2 equations by a constant. I'm going to do it again. I'm just technically showing you how to get row echelon form. You would technically need to keep going to get the proper form of multiplying by 1/2 and multiplying by 1/4. But once again, we're not robots. You could automatically just start plugging and chugging. You would get some nasty fractions, but it would be all right. Or you could get it in the proper form first. Let's see, multiply 1/2. We have x plus. Ricky is saying like, ew, this is going to be kind of gross for these odd numbers, and he's right. They're not pretty. But it'll work. Then we multiply the next one by 1/4. So we get 1y plus 3/4 z equals 10/4. My 3/4 z, I don't know what I wrote. I said 3/4 z. Equals 10/4. Is that 5/2? Name of the game. Let's plug and chug. So y plus 3/4 a equals 5/2. So y is going to equal 5/2 minus 3/4 a. I should probably pause right now and say, hold on, has anybody found any mistakes? Now it's time to plug and chug to the top. Had to plug in both our z and our y. Not impossible, but messy. We end up with x plus 15/4 minus 9/8 a plus 3/2 a equals 7/2. Sadly, if you need to combine like terms, we're going to be moving this 15/4 to the other side. To do that, I think I want fourths up here with the 7 to meet them. So 7 times 2/2 would be 14/4 minus 15/4 would be -1/4, right? To combine these two, I'm pretty sure I want common denominators with my a's. So that'd be negative 9/8 plus 12/8. I think would be 3/8.
No, we're not.
12 minus 9. Positive, yeah. No, you're good. There's a lot of fractions going on. Whew, finally. And kiddos, could we rewrite them all in this nice little like coordinate x comma y comma z? Sure, but let's be lazy, something. We worked hard in our fractions. We'll just stop. We have our x, we have our y, we have our z. But one more time though, does someone check or catch a math error?
I'm sure there is one somewhere.
You're sure there is one somewhere?
I mean, it looks like
Are you
so
seeing
much.
one?
I don't think I did, but it's very easy when I'm doing, like, when I'm talking and explaining and doing fractions. Oh yeah, happens all the time. We're good? Did anybody, like, match it without just copying the work? Aww. I had a couple still coming. They might have just not got me yet.
So you have to use fractions.
Well, I mean, you have to end with fractions no matter what. Do you necessarily have to do the steps if you're not a robot of needing to get a leading coefficient of 1 and 1 and 1? I guess not. They still gonna get the same fractions at the end no matter what. They might just be written a little differently.
It's easier to work with the regular numbers.
Yeah, except like you're gonna, the way this is, you just get it by itself, get it by itself. There's no dividing. Let me check.
I guess it's technically.
It's 14 fourths minus 15 fourths, isn't that right?
Oh.
Is that okay? Okay. The last little bit of class, guys, we only have a few minutes, is homework help. Okay? Homework help. So, what's going to be different in section 7.3b? 7.3a is pretty straightforward until number 42, which we did together today, by the way. Right? 7.3b is shorter. I think I closed the homework assignment, but if you guys saw it, I don't think it's very long. This is you guys, right? Oh, no, that's not. I can pull it up so we can look. There aren't very many problems in 7.3b. If you didn't do 7.3a, well, you kind of have a normal assignment. If you did do 7.3a, you have a shorter one tonight. You didn't do 7.2? Then you're a slacker. Okay, so.
Ooh.
But you have a 3-day weekend, so you're going to catch up. Okay? Yeah.
Oh.
Hey, 1, 2, 3, 4, 5, 6, 7 problems. But let's do some homework help. It might get tricky.
Oh, thank goodness.
We only have like 8 minutes.
But I might not be here tomorrow because I might be sick.
Yay!
Alright, kiddos, here's the idea. I'm not going to go into tons of physics today. We've already done vectors, we've kind of done our physics stuff. But, alright, focus on it. Homework help, believe me, you're going to want it. If I talk about it today, I won't talk about it on, tomorrow. How many variables do you see up there in that equation?
A lot.
Technically.
4?
Yeah.
3. 4.
You have S, you have A, you have T, you have V sub naught, which is V sub 0, you have T, you have S sub naught. Now, long story short, this is an equation that models free fall. Free fall meaning you're not propelled, you don't have like a rocket strapped to your back, you're just falling, or a ball is falling, or you're throwing up a ball and it's coming down, or you're shooting something and then it's coming down to the ground. You're talking about gravity, which is actually this little a, that's acceleration. Gravity, initial velocity, initial position. But the nice thing is we're not in physics. We're not going to go into all that craziness. Instead, we're going to say there was some experiment done and at different times in the falling, at different times, different positions were recorded, kind of like a lab. Okay? And number 48, they gave us, let's see, if we know S's and if we know T's, how many variables are left? 1, 2, 3. If you know S's and if you know T's, there are 3 variables left. Hey, 3 variables like X and Y and Z? Yes, like X and Y and Z. So if I was to give you, or if you were to get from the data, aka from the problem. If you were to get 3 different points, 3 different S's and T's. If you had 3 different points, you would get 3 different equations, and from 3 different equations, did you solve for 3 unknowns? Yes. But really quickly, just to make your lives a little bit easier, let's not write it in the physics way. Let's go ahead and write it in a simpler way with just an A, with just a B, and with just an S, okay? You don't have to write all those little sub-zeros. That'll get really annoying really fast. Okay. Now guys, usually when they give us points, what do we do with those points if we're trying to solve for something? Plug them in, plug them in. So let me go ahead and quickly get, where are we at? 7, 2. Nope,
Well,
7.
if you say it that way, then you're saying 0 equals 0. So you have to put the sub-zero.
Well, the sub-zero is important in physics because it means the first velocity, because velocity changes in the first position. So for our sake, we'll just say V and S. Now, what did they tell you? At 1 second, your object is at 132 feet. At 2 seconds, your object is at 100 feet. And at 3 seconds, your object is at 36 feet. Then we can make 3 different equations with our 3 different points. And remember, our points are T and then S, time and then position. So, for the first one, we're going to plug in 1 and 132. When we plug in 132, that's like our y equals. And technically, I'm going to write it at the end because we're used to having 132 or the equals being down there. Now, if I plug in t, which is there, and t equals 1, I will have 1/2 a plus 1b plus s. If I go to plug in my second point, now my s equals 100. If I plug in 1/2 a times 2 squared, I'll have 1/2 a times 2 squared, which is 4, plus b times 2, which will be 2b plus s. Some of you are noticing, this looks ugly, so that's 4 over 2, that's 2a. That looks a little bit nicer. So we'll make that 2a. And if I plug in my third point, I get s equals 36. I get 1/2 a times 3 squared plus 3 times b plus s. And Tyler's back here saying, you know what? We could just make this 9/2 a. Why is this problem in this section?
Because you're going to have to do the thing.
We're going to have to do a system of equations. Now, hold on. Some of you are like, this is disgusting. We already have fractions? Wait.
Oh, you can take
We're not robots. How do we kill the fractions?
multiply by certain things.
We can multiply everybody by 2 here. Multiply everybody by 2 here. Rewrite, and then do we just do our links? First 2, second 2, the remaining 2, and then solve. Okay. So you're going to have maybe one, I think just one, where you're solving a system applied to physics for a position. But there's one other type of application you might see that might trip you up unless geometry. Hey, we're talking about that today.
Oh.
Wait, what? How is there a system of equations in this thingamabob?
Because it's just 3 lines.
Question. What do you know about 3 angles in a triangle? What do you know about 2 angles making a straight line?
It's 180 minus.
What do you know about 2 other angles making a straight line? Do we have a system? Yes. Now, is it pretty for our system, like for our way of doing the links right now? No. How would we make it nicer? Well, wouldn't we need to go ahead and get like all the x and y's and z's all nice and lined up, right? But we can line it up pretty quickly by getting all the variables on one side, all the numbers on the other. You can add my 7, you can add my 7. 2x plus y equals 187. Minus 7, minus 7. 2x plus z equals 173. Kiddos, can we solve that? Yeah, we can. Now, some of you guys want to, I don't know, enjoy the freedom of not being robots and make up your own way to solve it. You can, but can't you just follow our system step by step and get to the seconds, but don't leave early or else I get in trouble.
How much
So stand near the door.
I get called out in teachers' meetings. Not my name, but meetings, not like. Bye guys, I'll see you later.
Is that Mr. Halliday that says that?